Dear student, I welcome you all in my math class. In this current semester, we are dealing with BTech second semester engineering mathematics, which is mathematics 2, and multiple integral or multiple integration is the first module that you all know. In this lecture, we'll be discussing about one very important process or method by which we can find out the value of double integration easily. So to understand this technique, so I'll first consider the conventional, that is straightforward technique. From there, we'll see what is the difficulty to find out the value with the help of the conventional method. And after that, ultimately, we'll use change of order of integration, and accordingly, we'll find out the value of the double integration. So here we have to find out the value of this double integration. So it is clear the first integration ranges from 0 to 1 and second ranges from e to the power x to e. And here the integrand is 1 by log y. So we have to integrate according to the problem with respect to y, then with respect to x. So as in the problem, method is not mentioned. So first we'll use the conventional method, which is straightforward method. Now, according to the straightforward method, the first step is that from this integration, first we have to consider the range for x as well as y, because this is the problem based on Cartesian coordinate. So how we can consider this range? That we have to consider from the observation. Now see here, according to the range contains the function of x, which is e to the power x. So we have to consider whether this integration over x or y. So one thing is clear, if I consider x ranges from e to the power x, so this is absurd. So we can't consider x equal to e to the power x. So surely we have to consider y equal to e to the power x to e. And for that, the other integration will be for x ranges from 0 to 1. So this is basically the conventional technique, or you can say straightforward technique. So after considering this, what we have to do now, we have to find out the value. So as the range over y-axis contains variable, that is e to the power x here, so we have to integrate with respect to y first. Now if I consider the integration with respect to y first, so x ranges from 0 to 1 is now fixed. So first we have to consider the integration for y, which ranges from e to the power x to e, and here integrand is 1 by log y, and we have to integrate with respect to y, and after doing this, ultimately we have to integrate with respect to x. But here the main point of concern is that can we integrate 1 by log y with respect to y easily? So this is a question. According to higher secondary level knowledge, or you can say according to the up to the first semester engineering mathematics, we can find out the value of this integration easily. Maybe there are some technique by which we can find out the value, but due to the restrictions for BTech student, so you know higher secondary level integration and you have learned some improper integration, which are the part of the definite integration in the first semester. So what we can say, according to higher secondary level, we can't integrate easily. So that is why we have to consider change of order. Now, when we consider change of order, so we have to consider the diagram of this region of the integration. Otherwise, if we able to find out the value in terms of conventional method, then we can do it directly without considering diagram. But if we use change of order, we have to consider diagram, and from there we can change the order. So you can understand as the range contains e to the power x. So here we have to know the diagram for e to the power x. So for you, I have considered this diagram, and this is very simple diagram that e to the power x is always non-negative, in fact positive. And here I have considered one part, like x value from -6 to +6. This is not like that, but I have considered the part of this diagram because you can understand, you can draw this graph for entire real axis. And from this diagram, one thing is clear: this graph is increasing. So if I consider the x value from negative to positive, so this is increasing. Now to use change of order of integration, so first consider the range according to the given problem. So already we have discussed about the range. So the second integration is basically over y-axis, and first integration is for x-axis. So for this integration, so consider the graph diagram basically. So this is x-axis and this is y-axis. And see, as y contains variables, so we have to consider this region with respect to y first. So the lower limit of y is here e to the power x, and see here x ranges from 0 to 1. So we can start by considering x equal to 0 here. So e to the power 0 is 1. So when x is 0, the y value is 1. And as you know, exponential function is increasing. So though this is the rough diagram, but still we can draw this graph. So this is e to the power x. So this one is graph of e to the power x. Obviously from 0 to the positive part. Now we have to consider e, and you all know e is a real number. Basically, it is a number lies between 2 and 3. So consider one value. So upper limit of y is e. So here you consider, one thing you can do, you just use some different colors so that you can understand the region easily. Now for upper limit of y, consider the value which lies between basically 2 and 3. And you all know when y is constant, so this is parallel to x-axis. So this is y equal to e. Now consider a range for x-axis. So here lower limit of x is 0. That means this is y-axis. So x equals to 0 means y-axis. So this is x equals to 0 and x equals to 1. So when x equals to 1, so this will be a line parallel to y-axis. So here, so this is x equals to 1. So what about this intersection point? Now basically, if I consider x equal to 1 and e to the power x, so this represents e, and here y equal to e. So that is why this intersection point is basically 1 comma e. Okay, now what about the region? Now see here, we have the bounded region bounded by this portion of e to the power x, y-axis, and this line y equal to e. So this one is the region R. Region R. Now, according to the problem, as y, that means range for y contains variables. So basically, they have given this problem by considering the vertical step. And one thing we have to know, for Cartesian coordinate, basically we can consider two strip. One is either vertical strip, other one is horizontal strip. So according to the problem, they have considered the range in terms of vertical strip. So you can call it just V. But we are interested to use change of order. That means we have to consider horizontal strip, and this is important. So here, due to change of order of integration, and already I have discussed, so if we integrate conventionally, so this will be complicated. Rather, we can't integrate the integrand 1 by log y with respect to y. So that is why you have to consider change of order. So here you consider this horizontal strip, let's say h. So for this horizontal strip, which is h, so we have to consider the range for x as well as y. So for horizontal strip, always we'll consider range for x-axis first, because in the range of x, we have to consider the variable which is y. Now, how we can consider the range for x? Now, for this horizontal strip, one thing is clear: the lower bound lies on y-axis. That means x equal to 0. So x ranges from 0 to, we have to consider the upper limit of this horizontal strip. So for this horizontal strip, upper limit lies on this curve, which is e to the power x, and so here this is y equal to e to the power x, and from this if we find x, so what will be x? Now x equals to log of y. So for this horizontal strip, x ranges from 0 to log y. Okay, now we have to consider the range for y. So how we can consider the range for y? Now the target is simple. We have to cover, or we have to traverse the region R here with the help of horizontal strip. So how we can traverse? Now if I move this horizontal strip downwards as well as upwards, so you can understand, if I move along y-axis in downward sense, so we can reach up to this point, and this point is basically y equal to 1. So this is the line where y equal to 1, and if we move upward direction in the direction of y, so we can reach up to the line y equal to e. So here, for this horizontal strip, y ranges from 1 to e. Now we have to find out the value of the integration. So this equals to, according to change of order, now we can write x integration first, because x contains variable part. So x ranges from 0 to log y, and finally we have to integrate with respect to y, which ranges from 1 to e. And one thing, so first you can write the integral part. So as this is given dy dx by log y, but as x contains variable, so we have to integrate with respect to x first. So here we have to write by using change of order of integration. Now from this integration, as we have to integrate with respect to x first, so with respect to x, other variable, that is y is constant. So x ranges from 0 to log y. As y is constant, so 1 by log y is also constant. So this is free from this integration, log y. And finally, we have to integrate with respect to y. So y ranges from 1 to e. And here over x, so this is only dx. So we have to integrate with respect to x first, and then we can integrate with respect to y. Now see, with respect to x, this integration becomes simple. So everyone can find out the value of this integration, which is basically integration dx, and you all know this is x. So this is a part of the definite integration, so we are ignoring the integrating constant. So y equals to 1 to e. Now the integration value with respect to x is x. So as this is definite integration, so we have to find out the value for x, which ranges from 0 to log y. And you all know, with the help of fundamental theorem of integral calculus, we can find out the value by putting upper limit minus the value of the integration by putting the lower limit. So integration over y ranges from 1 to e. So when upper limit of x is log y, so here the integration value is also x, so we can directly substitute. So due to upper limit, the value of the integration is log y because the integration is x, and minus due to the lower limit where x is 0, so we can substitute x by 0. So basically, this is only log y, and one thing, 1 by log y as the multiplier that already we have. And see, now the entire integrand becomes function of y, so then we can integrate with respect to y. And the most important observation is that here log y is cancelled out. So now this integration also becomes simple. So this is basically integration over y ranges from 1 to e, only dy. And you all know the integration value is y, upper limit is e, lower limit is 1. So the value becomes, due to upper limit e and due to lower limit 1 with negative signs. So the value of the given double integration is e minus 1. So if I summarize this value of the double integration, initially what we have seen, according to the conventional method, that is straightforward technique, we were unable to find out the value due to the complexity of this integration 1 by log y and integration with respect to y. But if we use change of order of the integration, we can easily find out the value of this double integration. So this is the advantage of change of order. Otherwise, if we are able to find out the value in straightforward sense, that is in conventional way, always we will do this. Otherwise, we have to change the order of the integration, and then we can find out the value of the integration if exists. So here I have considered one similar problem, but you have to try to find out the value of the integration with the help of straightforward technique, that is conventional technique. If you will unable to find, then only you will use change of order. So as of now, this is your task. So if you will unable to do, then obviously in the next class, we'll consider this problem. Up to this, I hope you all have understood about change of order of the integration and its advantages as well as disadvantages. Disadvantages is basically we have to consider the change of region, and for that we have to draw the diagram, whereas in straightforward method or in conventional method, without considering the diagram, we can find out the double integration value. But to perform the double integration, that means to find out the double integration value, so always change of order of integration is very, very important technique, because sometimes we can't find out the value of this double integration due to the complexity of the integrand, but with the help of change of order, we can easily find that value. So by this, thank you all for seeing this lecture.